Welcome back to video 3 of the CARF beam super fast RC jet build, and we're making some great progress in this video. Wing is done in the last video, and now it's time to jump back into the fuselage and getting stuff assembled, organized, laid out, and all of that stuff. So let's dive back in. So while we were painting bits and bytes on the wings, we also painted the tail section there black. We do have to do some sanding here as well too. So our little bump outs, those need to be sanded off by maybe about 3 millimeters. So not worried about that, but we got to take our Dremel and get all that done when the paint is dry. So that's ready to go. Last episode was all about the wing. So the wing is complete and ready to go. And with painting, we also need to paint our intake as well too. So this is the next thing to get going. And reason for that is we have to get this painted so it cures, because I think we'll be installing this pretty quickly into the fuselage. Other thing we're going to do with the full bypass setup is I was just making sure things lined up here and everything. We will be installing some BVM ceramic heat shield material all in this area. So essentially we're going to sand down the entire tail cone section here. We will put a piece of tape there, and this entire piece will get painted. And then our top cover, which is actually the bottom cover, because this is installed like this when you're looking at the underside of the aircraft. So when this gets installed like that, this is actually the underside. But we will do the same thing here. So we'll basically put a tape line across there, sand this guy out, and put a few layers of BVM heat shield, which is ceramic paint basically, in those areas. So we'll kind of get that painting stuff queued up and get rocking and rolling on it. All right, so visible intake duct is painted. Now we'll sand out our bypass and get that ready for our heat shield. A little plug here for turbines and tumbleweeds and all of our 2025 sponsors, also RC Event Hub. All right, so we got our bypass areas here sanded out, and we've got them taped, obviously. You can see the difference between the sanded areas and the stock areas. It's important to do that, otherwise your heat shield is likely to peel off. Okay, so heat shield, if you've never used it, it's kind of an interesting product because it's ceramic paint is what it is. So I think it's water-based, I believe. Water-based ceramic barrier coating. So is very common back in the day with BVM aircraft. Can be very useful for areas and that are prone to heat. And it just helps provide one extra layer of protection to make sure that things don't burn to the ground. It is sort of heavy, so you want to kind of keep it to a minimum as far as area goes, but it can be quite valuable in preventing issues. So usually I find it takes about 3 heavy coats to get it to be sufficient thickness. So you can see there, we've got it installed fairly heavy. Some blank areas there or lighter areas, so that's fine. So we'll let that dry and we'll put the next coat on and then one more after that. All right, so stock bags, bladders. Initially, I don't know how these things are gonna fit in there because it's tight. They look like they're gigantic, so that'll be interesting. The manual shows holes right there beside the intakes, and our kit does not have the holes. So I just got those bags kind of mocked up, lined up, and now we will drill a hole through there. I'm just gonna be careful initially because I don't know how close those intakes get. That's just the impact doing its thing, by the way. Okay, so that should be okay. I'll grab my 90-degree attachment. Yes, we're mixing Milwaukee and DeWalt. I know some people are going to be triggered by that, but it's okay. All right, so I think that should work. That's where it says to run the holes, or that's where it's supposed to have the holes. I guess our tubing, comes out the bottom. All right. Okay, so it looks like we do have a path beside the intake ducts. We did put our second coat of heat shield on our bypass, and you can see there it got a lot more solid white. So we'll let that dry still, and we'll do one more coat after that. So just fitting the ductwork and everything in place here, and I think looks like everything's going to line up well. We did open up our back former here with the Dremel a little bit to get that pipe in, and now it's nice and snug, but you can still get it in and out fairly easy. So as far as positioning goes, if we take this duct and push it all the way forward, and then get our lower bypass installed where it's comfortable, it's going to sit something like that. And that also means that our tail is nice and flush with the back of the aircraft. So everything looks like it lines up very nicely. So happy with that. So what we'll do initially here so we can save our position is we're just going to take our white paint marker and trace around the lower bypass area. So now we have a repeatable spot where we can pop that back in, which is needed. And now if we just take the top, our heat shield here is basically dry. We still have to put another coat on, but I'm just playing around with the fitting obviously here. So bypass halves, basically if we just get those guys lined up, top and bottom, everything looks really good. So that fits really nice. Unlike the Ultra Flash previously, you'd use like a Velcro strap to hold this together. And in this case, you're actually screwing down the bypass, which is amazing. So, and then just taking a look at this now, I think a lot of our bag, our fuel bladder actually sits kind of in this area as well too. So we do have a fair bit of room that I wasn't really thinking about. Initial looks here is we're going to have to obviously get rid of this sharp piece right there, which is fine. So we'll pop our bypass out now, and then we will get another layer of heat shield installed. And now that we've got that repeatable location for where it's actually going to sit, we can work on getting our turbine mounted. And before we disassemble the whole setup here, drop the engine in and confirm that our alignment is good. So I've put this in place. From the back end here, confirmed that our alignment side to side is good. Up and down is very, very close. So what's going to happen is we are going to, and this is covered in the instruction manual, we are going to cut out the area of the bypass where our mounting plates are going to go. And the engine will be mounted on the, in this case, the underside of those mounting plates. And what that does is this brings the engine towards the top of the aircraft, which is our current bottom, and that brings everything into alignment. So we'll have a little sliver of the bypass maybe left here, not much though. And actually what I might do in that case is take my mounting plate and kind of skew that more forward so we do have a little bit left back here. So we'll have to see how that's going to work out. And yeah, so that's how we're going to end up mounting the engine, which should work out beautifully. All right, so one of the questions I think I saw on Facebook about the beam was positioning of the tail cones. So I guess if we do it like this, that's going to be the easiest way for me to show you guys. So in a bypass like this, it's, in my opinion, it's a little bit less specific as far as turbine depth. So with that though, I treat this portion of the bypass as a normal large opening on a pipe system. So if we didn't have any of this bypass stuff and this was our intake of our pipe, I would treat it basically, we would split the difference. Now the top side, it's cut a little bit shorter than the bottom side. So if we take a look at this, we are sitting at about, let's just call it 3 inches for our intake. So what does that mean? That means that we're going to be putting the end of our turbine at about the 1.5 inch mark, which is exactly where I got this visually lined up to. So right about there is about 1.5 inches. So we've got our corresponding marks there. So that's how I line it up. And what it looks like in the bypass is like that. So these turbines, these Chikoi turbines, are so small that the turbine barely rests by like 1 millimeter on each side. But that's kind of where it's sitting, right like that. So I've cut some G10 material. This is 2.5 millimeter material. And what we're going to do is we are going to bolt this to the mounting ears, just like that. So the next thing I want to do is cut 2 pieces off that are exactly the same length as these mounting tabs. We've got the little cutouts done in our lower bypass. Now essentially the top bypass gets exactly the same cutouts. So what happens is when we take this out, we'll match those guys up together, do the exact same cutout on the top portion. Then when that bypass gets installed, you'd put a screw through here, 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 and here. That's why I tried to keep as much as possible on these back sections. So ultimately though, this is going to work out great. So our little mounting ears that we made here, you can see how those guys work. So the bolt heads sit inside the bypass, and that's going to work wonderful. So it should be a good setup. Now we'll pull all this stuff out, we'll clean it up a little bit, clean up our white marks, and we'll get the top portion of the bypass cut out to accommodate the turbine. So just following the manual here and installing the velvet where it says, so we've installed the larger piece of the 2 right there. And now it looks like we need to get all of our ductwork and everything installed, and then we put the other piece over top of the ductwork. To glue that in place, I'm just using goop here. So just kind of putting a long bead and then just tucking this guy up and laying it in place. So should work well. And we've got the pipe mounted to the bypass with the supplied hardware. And when I tighten these guys up, I put a little bit of rubberized CA on the threads, and that will do a good job of holding it in place. Now we'll just get that installed. So we are ready to install the engine. I drilled a hole here, put a rubber grommet through. Those are not supplied with the kit. We've got snakeskin over top of our turbine wire, and that's ready to drop in place. Let's see if I can do this one-handed. Oh yeah, so good. Beautiful. So ready to bolt that turbine in, and then we got to think about our fuel line here, but we also have to work on our velvet, or our, I think that's velvet. Anyways, fabric install on this stuff. Now, the manual actually does show this piece being left, probably for rigidity. I don't think I like that very much. I don't like this sharp piece, even if it's covered with this stuff. So I think we're probably going to sand that down, is what I'm going to do. All right, so turbine is installed for the final time, and we've got our bypass installed as well too. Put a drain hole on the bypass. That's just good practice, and obviously doesn't really have anywhere to drain because the wing sits right here, but that's okay. Probably put a drain hole right here as well too, because the wing kind of has a little channel here that the bypass sits in. So we put a drain hole right here. At least fuel has a path to get out if needed. So I'm going to fire up the Dremel and the vacuum, and we're going to take care of these little ridges right there as well. I did run our fuel tubing as well, the 4mm Festo line forward. I just ran that through the same grommet as the line. So you can see there, we've got the end pinched off so it doesn't get fouled with anything. So let's sand this guy down, and then we need to put our velvet on the ducting side of things. All right, so we got our velvet installed on the duct side. So I put a strip of shoe goop right there. You can kind of see the dark area and a little bit right there. So we've got that first part installed, so we're gonna let that cure. The important thing to cover here, obviously everything, but the important thing to cover is that ridge. We sanded that down a ton, so it's still a bit of a ridge right there, but it's nice and swooping instead of being a sharp 90-degree angle. So I think that's a good thing to do with the kit. Doesn't change the structure of the ducting at all, so happy with that so far. So basically from this point forward, we are good. The next thing to do once we're ready with this stuff is we're going to tuck the fuel bladders in here, and we need to get our fuel tubing hooked up to the bladders. And then once that fuel bladder is installed, then I'm going to put the wing on and just kind of get that stuff, get those bladders kind of sitting in there, how we're actually going to have them installed. So it's been a couple hours and our goop is now cured and our fuzzy stuff is stuck in place, which is wonderful. We are going to prep our fuel bladders, also known as fuel containment devices, to go into the aircraft. Now, when they come in the package, this is how they're organized. These won't really fit or fit their intended use in this format. So when we filled this one up just to play around with it earlier, this is the format that it needs to be in because our fill line needs to be at the top of the aircraft. So this is going to sit in just like that. Definitely odd. I thought initially that this would be a lot more area for these bladders to sit in, but we'll see how this goes. Yeah, I'm assuming this is going to work because I know CARF's already been using this, but we'll see. So I don't like to use the Festo fittings on a good day, but I don't like to use the Festo fittings in a scenario like this where you're kind of buried and this might be sitting in the aircraft getting pushed around, adding side force to these fittings, which isn't really good. So it's not easy because this is a metric size. So this Festo fitting is designed to fit the 6mm outside diameter tube. So this 6mm outside diameter tube is designed to push on that fitting. This fitting also fits on the tube of these tanks. So that is a 6mm outside diameter fitting right here. What we need to do is get this 4mm inside diameter over top of that 6mm outside diameter. Doesn't seem like it's possible, but it is possible. I've done this quite a bit in the past before we were using any of this style of fitting, so I'll show you guys what we're doing. So this length of tubing that I cut was the setup for the fill line. So I'm assuming this is going to come to the front of the bladders. We'll join these together and we'll have a single fill line, so probably have to cut some of that off. And we'll probably put a similar size tube on the front. But this is how we get these guys installed. So first thing we need to do is, you can see there, they're basically exactly the same size. All right, so we need a pair of pliers. I kind of like these guys the best because they spread it out nicely. That style will also work, but not quite as well. So first thing we want to do is we want to put a bunch of saliva inside the tube. Reason for that is we need that tube to stay in good shape, and then we also need our pliers to slip in and out of there no problem. So we can also use our heat gun on this, but the lighter is kind of quick and easy. So now we take our pliers, put those on there, and I'm just going to go like that and get it kind of spread out. Now this cools off pretty quickly. But that's basically what we're after. Now we can slip that tube over top, put safety wire on it, and then we put some shrink tube over top of that whole contraption, and it works very well. So it's still not easy, but it makes getting that tube over now more possible. Perfect. So that's what we're looking for. Now I'll grab some safety wire and we'll get that wired up. All right, when you're working around the bladder bags, obviously you just want to be mindful that you're not poking it with your safety wire. That should be pretty obvious, but always be a little bit more cautious and pay attention to what you're doing. Okay, so now we're going to slip that over. Now, I have used the Festo fittings on my other aircraft that I have installed this style brand of bag in, and it works amazingly well. The reason in this case that we are not going to use them is because, as I mentioned, this stuff is kind of buried in the aircraft and it's probably putting some sideways force on things. So that's why we're doing this route. All right, so now we're going to take some 3/8 shrink tube. We don't need to go too crazy here. Just over top of the safety wire is basically what we're protecting. So you can see there I've got the safety wire end pushed that way, away from the tube. Now we'll go like this. And in this case, I'm going to use my heat gun to get that guy shrunk down. All right, so now we'll just use a little bit of heat. And that's that. So that's our line successfully installed. So definitely an interesting setup. I mean, we don't have hundreds of planes put together with fuel bags, but we've got a decent amount of experience with these things now. And this is definitely new, having them just kind of jammed in there. It's going to be interesting. So what I'm going to do now is I'm going to get the wing put on. And the reason for that is then we can flip this plane over and kind of see how everything's jiving from the top side. Like, I don't know how this is going to work, how much fluid's gonna fit in there, I don't know. The nice thing about the fuel bags with a saddle tank setup like that is if one pressurizes all the way, the other one keeps filling until they're both pressurized at the same amount. So that is kind of a nice thing with the fuel bags is, you know, if one pulls dry, the other one keeps pulling, right? Because it's not pulling air. That's a great thing. So anyways, we're going to bolt the wing on and see what this thing looks like from the top side. And as we flip the fuselage around and start working in the front end, tell you what, this light is amazing. So these work lights are phenomenal. These will be listed on our website very, very soon. By the time this video comes out, it's likely they'll be on there. They clip on to the fly right stand beautifully. They fit on basically any work stand. They last like 12 hours and they hold themselves in the right spot. So absolutely great. Thank you, Joe, for creating this thing. But definitely encourage you guys to check it out, thelightersideofrc.com. And I'm not sure where these will be listed, but they'll be listed on there somewhere. All right, so as we get into the front end of this aircraft, things get interesting. I did blow into the bags and it doesn't seem like much is going in, but you gotta remember that the air is not gonna be as good at filling in all the cracks in the bag or the space in the bag as fluid will be. So it'll be interesting to see how much actually goes in there. So it's time to start organizing our front end. We've got all of our tubes and everything run forward. This is our wires from the back end. And of course our wires from the wing, the plugins are right here. So it's gonna be a pretty simple wiring setup. We just need to figure out where our equipment's going next and we'll kind of go from there. But I think the next thing we're gonna jump onto is the landing gear in the front. And because we're using Electron, the manual doesn't really show how this is all supposed to work. So if you look at the manual, it shows you the JP landing gear, which mounts to the underside, or from the underside of the gear mounting plate. But I think our electron mounts from the top side. I tried to put the electron in like this and it doesn't fit. I tried to put it in on the top side and it's much closer. So what are we going to do to solve this problem? Well, first thing we have to do is find out roughly where this is all supposed to mount. So I've got the plane visually kind of leveled out. I'm going to take my tape measure, we'll go to the bottom of the wheels. Actually, we'll do it like this. So bottom of the wheels, we are at 26-ish inches. So if I take that same measurement here, that gives me an idea of where my leg should be sticking out, which ultimately helps me determine whether we're mounting on the top side of the trunnion or the bottom. So if this leg is just outside of the fuselage, we're at 26 inches. So that's very close. So now I know, based on that, where my gear stuff needs to mount. So if we were to mount on the top side, I'll just pop this in. So like that is where it would go on the top side. Then we are, I think, pretty close. I mean, This is one of the downsides of being the first. So if we do that, we are at 26.5 from the ground. So pretty stinking close, but our gear plates are also that 1/2 inch thickness. So the landing gear would almost perfectly mount like that. Like it's almost bang on perfect. All we would have to do is a little bit of sanding right there to make everything sit down 100% perfect. So if we try and flip it around, okay, so now if I try and go in from the bottom side like the other gear is shown, basically I would have to completely sand down this section right here. I'd have to get rid of one of those 3 layers of ply because the motor prevents that from sitting against the leg properly. All right, so here's what I'm going to do. I think what I'm going to do, I'm going to do a little bit of sanding right here first on that piece. We are going to then get the landing gear installed. We'll hook up our manual controller. We'll see if it works on the top position. If it does, we will get this screwed in, and then we'll put our leg on the bottom, get this plane on the ground, and we'll see how it sits on the ground. Obviously, if it's nose down, that's going to be no good. So let's, I guess that's probably the only way to do it. I did some rough calculations here, some installations, and we definitely have to install the landing gear from the bottom side, which kind of sucks because that means that in this area, we need to do a whole bunch of sanding here. So essentially the motor for the Electron and the mounting plates of the main body are, let's say, this narrow apart, and that gear mount is this narrow apart. So we have to sand the top side here to make room for that whole gear to sit flush. So I did get it sort of mocked up and installed and mounted from the bottom like that. We are at 26 inches. So we basically match the back wheels, which is where we need to be. So kind of sucky, but that's what we need to do. So I'm going to pull this guy out, and basically we're going to take off about the width of one of these pieces of wood from this mounting plate for the front gear. And just to share with you guys exactly what's going on here. So if this is the bottom of the gear mounting plate, so we've installed the gear from the bottom of the aircraft and it's sitting like this. In order to level that out like this, we need a decent amount of space right there. So what happens is our former work is basically 12 millimeters. And if you look here, it interferes with the mounting tab. So if we were to take that and drop it down, so we're likely looking at about 2 millimeters we need to take off that, that mounting plate. Because if our mounting plates were 10 millimeters, then we would be okay. So basically what we need to do, and you can kind of see the marks here made by the motor, but we need to take off 2 millimeters of this material right here in order for that motor to sit down properly. So not a huge amount, but it's going to be a little bit of a pain to get in there, that's for sure. So let's fire up the vacuum, the Dremel, and do some sanding. And with a few millimeters off of that plate, everything is going to work out well. So you can see right there, we've sanded off one of the layers of plywood about 7/8 of the way through, so almost all the way through one layer of plywood. And we know that this is good because if we get that centered like that, so if I take this gear itself from the underside and push up, I know the gear's sitting flat right now, and then if I take the motor and push down, I've got a little bit of room there where the motor's pushing down. So that should be good. And one of the other considerations with the Electron stuff is if you look at the arm, right there, the steering arm, we can run this gear more forward, but then our steering arm interferes. So if we run that steering arm like that, or the whole gear assembly rearward, just enough to clear that steering arm, we should be bang on perfect. So I think that is going to work well. So what I'm going to do now is I'm going to flip this airplane over and we will get the gear mounted from the underside. All right, so I think we're good with this, guys. I did a little bit of sanding on our length here, so I just took off maybe 1/4 of an inch and kind of rounded it off to allow that wheel to come out properly. But I'll show you what this looks like as we retract it back in. Nothing's screwed down, so we kind of have to play with it, but so I think that should work out quite well. So now what I'll do, I'm just checking our clearance and stuff here. I think we're going to be fine there. We're going to use a clevis on this side, and we'll see what we have to use on the other side, but I think that's a good spot. So now we just want to make sure we're centered in the opening, of course, and then we will get our screws mounted and such. We haven't mounted our servo yet, so that's a consideration as well, but we should be good if we get this all lined up, and then we can pull the leg out and get our servo mounted now that we know we've got space for everything. All right, and I think we've got everything licked with the gear. Perfect. And the front landing gear is all ready to install, so we're centered, everything's working well, we've got our linkage set up. Initially I was going to go ball joint on the servo end, but because this is such a nice perfect setup here, we went clevis, which is great. So if you're using the CARF clevises on the Electron side here, You may be able to see that, but I did a little bit of sanding on that steering arm. That's just because these clevises are a little bit shorter space-wise there compared to the Sullivan Golden clevis. So this is a Golden clevis, but it is in metric size. So the reason I use the Golden clevis on this side is because it fits in the arm better. So anyways, that's our setup for the landing gear. Everything's been Loctited. It's very important that you Loctite your bolts or your fasteners holding the steering plate onto the trunnion. You have to take the things apart in order to do that. And we've also got our wheel fasteners there Loctited, and everything is lubricated and ready to go. So now with our previous 2 holes that we drilled, I only did 2, 1 per side initially. And with those guys done, what we can do is get it installed. I did put some thin CA in there earlier, and it should be good. I'm hoping all of this stuff just drops in. I don't know yet. Oh, look at that. It's like it was designed to fit in there. Perfect. Now, I'm making the assumption that when we extend this, the arm and stuff will have room right here. We may need to open this up a little bit more. As I've mentioned already, this is designed for JP gear, but we made the electrons fit. So first 2 screws are done up. Before we go any further, we will plug in our manual controller and confirm that these guys work. Okay, so we do have some sanding to do there. All right, so we did a little bit of sanding with our Dremel. Let's try that again. I think we may have to do a little bit more right there, which is fine. Okay, so what are we hanging up on now? Jeepers. All right, so I'm not really sure what we're hanging up on because there's nothing touching anything. Oh. Yeah. All right, I'll pull this apart and show you guys what's going on. All right, so fortunately it's actually an easy fix. Initially I thought it was the servo hitting the body. I have dealt with that before and I needed to do a little bit of sanding there, but in this case it's our fastening hardware. I put a nut on there and a washer just to prevent a bunch of this from sticking through, but obviously the nut is, or the head of the bolt, well, all the hardware is interfering, so we've got to change that. All right, so we've got it back in. We've got the fasteners modified there, so let's see what happens here. So we shouldn't get hung up initially. Nope. And nice. Cool, we got lots of space. That's great. So that worked out good. Yeah, that's fine. So that mount is good. Obviously, the kit requires some modifications, but works well, possible, all that stuff. So just gonna take a look at the wheels here. That looks good too. The wheels look like they're all sticking out the same amount. So side shot here, a little tough to see with all the stuff in the background, but the wheels are all very similar in sticky outiness. So now we'll retract this. Wicked. So we'll drill our other 2 holes, get our other 2 fasteners put in, and our front landing gear is done. I was going to check that. Yeah, we're good there. So we've got clearance, the wheel spins, so that's perfect. And there's a shot of the top side of the landing gear installed, so all nice and clean. Now I'm going to start working on the front end towards the center part. So I've got some good ideas for our cone area. So as we've mentioned previously in this project, the cone is going to stay on the aircraft. So the reason for that is we're putting a pitot tube in the nose. And while we've got the pitot tube in the nose, I figured it's a great idea to put our clone or receiver number 2 in the nose section, as well as our 900 as well too. So that's going to work out very well because all that will be hidden but still accessible in the nose cone. Obviously it's away from all of the devices and stuff, so that is going to be a wonderful setup. So we'll start off with our M-speed sensor and then we'll go from there. So let's pull that out. All right, so we've got our pitot tube installed there. There's a little bit of filling and stuff to do around the edge. It's on a sharp plane like this, it's really hard to keep everything. So we start with a small drill bit and go up to an 1/8 inch size, and that pitot tube just fits right through, but we do have a little bit of touch up to do, but that's what it looks like from the inside. So I kind of just get it tack glued with some CA, and now I'll drop some goop in there and let that do its thing. All right, we're gonna go a little crazy on this, this beam aircraft, I think. We're gonna do stuff a little bit different than the norm. So if you are putting together one of these aircraft, your results may vary. Don't do what we do what you wanna do is my best suggestion. So I think we are going to put a bunch of equipment in the nose. I just put some goop inside the nose there. That's why it's sitting like that, so the goop can run down and encapsulate the pitot tube. So in this aircraft, we've got our primary receiver. Primary receiver we will likely put in the normal location. We've got our RCSW on-off switch. We've got our pitot tube. We've got our 900 receiver. We've got our Rex 3, which is going to be our clone receiver or secondary receiver. And the other thing we have is our Jetty SPEC 30. So this is a cool device, number one, because we're using one battery on this aircraft. So we'll be using this battery to power everything. So this battery is going to split off and power the turbine, but also power all the electronics. It's a 3-cell battery, but the SPEC 30 is going to drop it down to 8.4 volts. The other nice thing about the SPEC 30 is this plugs into your primary EXT port. So if you're familiar with Jetty, you know this. So you have your EXT port. That plugs into the EXT port, so you get all the telemetry from the SPEC 30. But then our turbine telemetry plugs into EXT1, and our M-speed sensor plugs into EXT port 2. So this also acts as an EXT port splitter, which is fabulous. But I think the reason I'm telling you all this is I think I'm going to put all of this stuff in the nose of the aircraft. Why not? So with that, we've got our circle marked here. Now that circle is in reference to the nose cone spacing. So I still want to make this removable, but we want to have plugins here for all our devices. Now, one of the key things is I'm not sure yet where this battery is going to end up. The manual does show having 2 batteries mounted in that nose cone area, and I'm not sure if we put our parts in the nose cone area and if our battery ends up here, if that's going to be sufficient. Maybe we'll have enough weight forward for our nose that we can put our battery up there, as an example. I don't know yet. So we're going to kind of leave the battery location unknown at this point, but we're going to go with putting all these guys in the nose. So what does that mean? Basically, it means that we need to have power coming in, power going out to our turbine and receiver and everything. This guy needs to plug into there, which is fine. We need to have these guys. They're going to be daisy chained together like that. And these guys need to plug into the primary receiver, so there's going to be a lead coming for those. We also need some EXT extensions, so the owner can bind these receivers to his radio. And then the M-speed sensor plugs into here. So actually, putting all that stuff in the nose kind of simplifies things in some aspects. So I'm going to give this some more thought, do a little bit of planning on this guy, and I'm excited for that. All right guys, so first thing I did here is got our nose opening squared off. So basically just increased the circle to be a square shape. And now we've got space to install our plugs. So basically we've got power coming to the S-Spec from the XT60 plug. We've got power coming from the S-Spec to the MPX plug. So that's going to be our power system. What I was thinking about with this was, so if we get this installed here, the nice thing is this doesn't matter or doesn't change where our battery gets located. So if our battery gets located right in this area, we can have a plug here. That plug is going to feed this port, and then it's also going to feed the turbine. So that makes it nice and easy. And the intention here is essentially have these guys installed in this nose area, and then any of our servo plugs that for devices, they'll just fit around this perimeter. So once those are fit and everything, it should be super easy to get that stuff all sorted out. So really excited for this actually. That's it's going to make it a very clean installation. So we're going to get these guys. Actually, I'm going to fill this with aero epoxy around here just because there's gaps in the skin to the former. So we're going to get those guys filled up so we have something to screw into. All right, so we got our first components mounted on our nose here. One thing that's important to be aware of is the stuff we're putting in the nose isn't heavy. So in the stock case where you've got that carbon tube coming in, your batteries are mounting on the tube, that's because your batteries are heavy. These components we're putting in there are very light. I was thinking about that because I figured somebody's going to make some stupid comment about how you can't add weight into the nose like this and all that. So anyways, we're not adding a ton of weight in the nose, but that's the S-Spec 30, which is the heaviest thing. So we've got our connectors done up here. So this is going to be our power coming to the S-Spec 30 and power going to the system. So that is our setup for the nose. We still have our other two receivers to plug in, but our layout there is set. So additionally, I got now that our components are installed, so we've got our Rex 12, which is our primary receiver. We've got our gear controller and our Cortex at the back there. So those guys are all in place. So what that means now is we can get our wiring run to those devices. So what happened here is I got our end installed. You can see it there. So this guy's going to get screwed in. I enlarged the holes going through the former work there. So that's where all of our wires are going to go. And then where this plugs into the Rex 12 on the MPX connector right there, we're going to have another wire coming off, and that's going to feed the gear controller. So super simple setup, and nice and clean as well too. So that is our initial wiring. Now that we have this in place, we can kind of move forward with all the other installation in the nose. But with that, we're going to end video 3 here, and we will continue in video 4 with the rest of the equipment installation, the setup, test run of the aircraft, and it's going to be a great finale for the Beam aircraft. So stay tuned for that video where everything's going to wrap up. Also encourage you guys to check out the light setup at thelightersideofrc.com. This has been such a cool tool to be using over the past week. And again, thank you, Joe, for coming up with the design. It's fantastic, and I'm really impressed by it. So thanks guys so much for watching the video series, and we'll see you in the next video.